So in these series on graphs of two variable equations, we've been analyzing graphs. We've talked about x-intercepts and y-intercepts and how to find those analytically. We want to introduce the concept of symmetry. So symmetry is when you have a mirror image about a certain axis. We have basically three types of symmetry we're going to introduce. We're going to introduce, first of all, x-axis symmetry. That's going to be our first type. So x-axis symmetry, let's draw a Cartesian coordinate plane where we have an x-axis and a y-axis. Let's say we have a bit of a graph here. Let's put in the upper right quadrant. That's the first quadrant, a bit of graph. Then if I have x-axis symmetry, I have to have a mirror image about the x-axis. So I'm going to have a bit here in the, what's called the fourth quadrant. That mirrors what's in the first quadrant. So let me pick a point. Let's call it xy. xy in the first quadrant. You got your x coordinate. You got your y coordinate. Now, notice that if we have x-axis symmetry, we have to have a point on the opposite side down there in the fourth quadrant. Now, what's the name of that point, you may ask? That's going to be x negative y. It has the same x coordinate, but the y is going to be flip-flopped. So here we have x negative y. Yeah, so the idea behind x-axis symmetry is if xy is a point on the graph then so is x negative y. Very important here. And we want to hold that fact. We don't want to lose that fact. So if xy is there, x negative y is there. That's for x-axis symmetry. Very important. All right, let's do another type of symmetry. We're going to call this one y-axis symmetry. You probably could have guessed that if we were doing x-axis. We're probably going to do y-axis symmetry. So here I'm going to draw my Cartesian coordinate plane. I'm going to put an x-axis up, a y-axis up. And let's start drawing in the first quadrant a bit of graph. I don't know how I'll make it. I'll just make it going up like that. So if we have y-axis symmetry, we're going to have a mirror image about the vertical y-axis. So we're going to have a piece going here in the second quadrant like so. So let me pick a point in the first quadrant that's on the graph. Let's call that point xy. xy. So I have an x coordinate of x, y coordinate of y. If you look over there in the second quadrant, you're going to have a point on the opposite side, right? Well, let's try to fill that in. This point over here is going to be x. No, it's going to be negative x comma positive y. So notice it's at the same y level, right? The y height is the same. It's just the x is flip-flopped. Yeah, so we have the same y coordinate, but we have a different x coordinate and negative x. So really the key here, it's not writing. The key here for y-axis symmetry is if xy is a point on the graph then so is negative x comma y. That's for y-axis symmetry. If xy is there, negative xy is there. Key, very key. So we want to hold that fact. Don't lose that fact for y-axis symmetry. Okay, we're going to move on to our final type of symmetry that we're going to introduce. This is a rather, maybe an unusual type of symmetry compared to the first two. This one is called origin symmetry. origin symmetry. So let's draw a y-axis. Let's draw an x-axis. And let's draw a bit of graph here in the first quadrant, and let's make it increase and then decrease. So if you have origin symmetry, you're going to have what I call what is catacorner to it. So notice how in the first quadrant we have a bit of graph. You're going to have something in the third quadrant that's catacorner to it. So some people might call this catacorner symmetry. Catacorner symmetry. So the idea is if I pick a point here on the graph in the first quadrant, let's call that point xy. Right, you have your positive x coordinate and your positive y coordinate here. You're going to have a point catacorner to it, in this case in the third quadrant. Think about what that is. That's negative x, negative y, right? The x is the opposite and the y is the opposite. Both of them are opposites. You got negative x, negative y. Let's actually locate those on the axes, right? Here's negative y right here. Over here on the x-axis, this is negative x. Over here. Yeah, so the really key thing about this type of symmetry is if xy is a point on the graph, then so is negative x, negative y. Yeah, so here we have three types of symmetry, right? We have x-axis, y-axis, and origin. And we want to keep those three facts in mind. For x-axis, if xy is there, x negative y is there. For y-axis, if xy is there, then negative x comma y is there. And for this origin type, this catacorner type, if xy is there, then negative xy is, I'm sorry, negative x negative y. Negative x negative y is there. Very important. Let's see if we can identify three types of symmetry just from looking at pictures. So examples. Determine what type of symmetry the graph has, if any. It may not have any kind of symmetry. Okay, here's our first example. We're going to draw a picture and we're going to see, can you identify if there's any kind of special symmetry here? All right, here's my graph going red. Oops, that's not red, is it? Not red at all. Let's call this G for graph. Does G have any kind of symmetry? The answer is yes. G has a y-axis symmetry. Right, if I pick a point over here, let's call that point xy, there's one on the opposite side of the y-axis, right? So it would be negative x comma y. Okay, let's scroll. Let's do a number 2 example. Let's say we have a y-axis and an x-axis again. And let's say this time, we're dealing with something Something like this. This is our graph. Let's call it G. So what about G? What about G? Does it have any kind of symmetry? Well, it should here, right? If I pick a point in my upper quadrant, it's called a green point. There is a point on the opposite side of the x-axis. There's a mirror image here about the x-axis. So if x positive y is there, x negative y is there. So this is x-axis symmetry, right? A mirror image about the x-axis. Okay, let's do a number 3 here. We have an x-axis and a y-axis. And we have a little bit of graph here in the first quadrant. And another little bit of graph here in the third quadrant. We're going to call this G for graph. G for graph, the red bits. So what kind of symmetry does it appear we have here? Well, it's kind of a catacorner thing, right? If I take a point here in the upper right quadrant, the first quadrant, there's one catacorner to it. So that's xy, there's one negative x, negative y. If I took one here in the upper right quadrant, the first quadrant, there's one catacorner to it in the third quadrant. If I took another point here in the upper right quadrant, the first quadrant, there's one catacorner to it over here in the third quadrant. So yeah. So here we're going to have what you call origin symmetry. Now let's do a fourth case. X-axis and y-axis present. And let's say our graph is a circle, just a circle here, centered about the origin. That's our graph. A circle centered at 0, 0. So what kind of symmetry does this have is the question. Well, first of all, you have a mirror image about the x-axis, right? If I pick a blue point in the first quadrant, there's going to be a blue point in the fourth quadrant opposite about the x-axis. So it definitely has x-axis symmetry. Also, you might notice that that blue point that I had, if I turn that green, I'll turn it green, there's a mirror image about the y-axis as well, right? If xy is there, negative xy is there, so we have y-axis symmetry. And finally, you might notice that there's a catacorner thing going on as well, right? A catacorner thing going on. Yeah, so that initial point I started with, there's a point down in the, so it's in the first quadrant, there's a point down in the third quadrant opposite. So it actually has origin symmetry. It has all three types of symmetry. A circle does. A circle centered about the origin, 0, 0 has x-axis, y-axis, origin symmetry. Yeah. All right, so this is just visually being able to inspect and tell if anything has symmetry, if a graph has symmetry. So what we want to be able to do is not just look at, the graph. We want to be able to look at the equation and somehow tell from the equation, because a lot of times we don't have the graph of equation. So we'll be looking at that in our next video.